84 divided evenly by 44. Split 84 into digits 8 and 4. Add them and you get 12. Multiply them and you get 32. Add those two results together and you land on 44. Stick around, we're about to find out exactly what this problem wants. N is divisible by the sum of its digit sum and its digit product. So you add up all the digits, multiply them all together and add those two results. If n divides evenly into that total, the answer is true. Otherwise, it's false. This is LeetCode 3622. Check divisibility by digit sum and product. I'm Kai. Welcome back to Fun with Learning Technology. You're given a positive whole number, n. Break it apart into its digits, add them up for a digit sum and multiply them together for a digit product. Add those two numbers together. If n divides evenly into that combined total, the answer is true. Otherwise, it's false. Let's trace the real example. N is 99 and its digits are 9 and 9. The digit sum is 9 plus 9, 18. The digit product is 9 times 9, 81. Add those together and you land on 99 again. And 99 divided by 99 leaves nothing left over. So the answer is true. N can be as small as 1 or as large as 1 million, which means at most 7 digits to work through. That loop is always short. And the digit product can climb pretty fast, but since we are only adding it to the sum before we divide, we never need to worry about it being unreasonably huge. Here's the plan. Walk through n one digit at a time, using mod 10 to grab the last digit and integer division by 10 to drop it. Keep a running sum and a running product as you go. Once every digit's been visited, add the sum and product together and check whether n divides evenly by that. One thing to check. What happens when a digit is 0, like in 105? The product collapses to 0. And that's exactly where people add a defensive if product is 0 skip it check that this problem doesn't need. We are dividing by the sum plus the product, not the product alone. And the sum of a positive number's digits is always at least 1. So the total can't hit 0. And there is no extra guard needed in the code. Worth double checking against the problem statement. It says add the digit sum and digit product together, then check divisibility once. On 99, 18 alone doesn't divide it and neither does 81 alone. Only the combined 99 works. So the combining step isn't optional, it's the actual rule. We keep a working copy of n called temp since we are about to tear it apart. Each loop, mod 10 peels off the last digit, refold it into the running sum and product, then integer division by 10 drops that digit and shrinks temp for the next round. Once the loop's done, add the sum and the product into one total. Then check n mod that total. If there's nothing left over, we return true. Here's the whole thing put together. Two trackers started off, sum at 0, product at 1, plus a temp copy of n to work through. The while loop keeps going as long as temp still has digits. Grab the last one with mod 10, fold it into the running sum and the running product, then drop that digit with integer division by 10. Once temp hits 0, every digit's been counted. The return line adds sum and product into one total and checks whether n divides evenly into it. A 0 remainder means true. The loop always ends because temp keeps shrinking by a factor of 10 each time. Sum and product build up together in that same single pass. So by the time we check divisibility, both pieces are ready. A single digit number can never pass. Its total is always double the number itself. So there's always something left over. A 0 digit inside the number, like in 105, is completely harmless. It just zeroes out the product's contribution. And the biggest possible input, 1 million, actually sails through. 6 0 digits collapse the product to 0. The sum is just 1 and everything divides evenly by 1. This is one pass over the digits. So it runs in big O of the number of digits. At most 7 digits here. Basically instant. Space is just a couple of counters, so that's constant too. Whenever a problem asks you to check a number against something built from its own digits, the pattern is the same. Peel with mod 10, shrink with integer division by 10, combine everything, then compare once at the end. Talk is cheap. Let's actually run this. I fed it all to all the problem's real examples. No cherry picking. Quick one, for n equals 100, One digit trips up the sum times product check. Pause and guess which. Take a second before I give it away. It's the 0. Any 0 digit zeros out the whole product. So the combined check always fails for a number like 100. Second one. If two numbers share both digit sum and digit product, do they always pass or fail together? Guess before I answer. Think about what the check actually depends on. Careful, sum and product decide the divisor, but it's n itself getting divided. So two different n's with matching sum and product can still land on different answers. That was LeetCode 3622. Check whether a number is divisible by the sum of its digit sum and digit product. The core trick is peeling off digits one at a time, tracking both sum and product together, then checking one modulo at the end. It runs in olog time with only one space, since you only touch each digit once.